Yes, ma'am.
Fine. So I'll start. So I'll share my screen. Give me a second. Okay, I think I shared my screen. Just a minute. I hope it is visible to every one of you.
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
Yes, ma'am.
Fine. So we can see. I think there is one example I have given, which is temperature and sales of steam. So this is firstly I will explain you the concept of correlation, and then we'll see how we can perform correlation here. So anyone can tell me if you have any idea about correlation?
In which we we try to see the relation between the two variables.
Very good. Yes, ma'am.
In which one variable is at what extent is effective on other variable,
This is so.
or have at what extent both of these have similarity.
Someone has written in the chat, Neha ma'am, relation between two or more variables. Very good. So in the simple form, I can say, when I talk about correlation, correlation is nothing but it's a study of the relationship between the variables, right? When we are studying the relationship between the variables, we can say it is correlation, right? In other word, I can say when you want to see the strength of relationship, or you can call it as a degree of relationship. We are using correlation. So correlation can tell you the strength, how strongly two variables are related to each other. That way we are using the correlation. Apart from this, one more task we can do with the help of correlation, that is we can identify the direction of relationship, right? Means in which direction two variables are going, whether they are going in a same direction or in opposite direction, that you can study using the correlation. I think I always explain this by the demand and price example. So maybe you have already studied this example in economics, if you have studied economics, or maybe if I can say if not, we have studied, even we have experienced this thing, that when we say this thing, the price of a particular commodity or the product or the services is increasing, generally demand decreases. I think this is the law says, right? And I think it is true also. So when price increases, demand decreases, or vice versa. When price decreases, generally demand increases. So that way there is an inverse relationship between these two variables, right? That means it's a direction. So that way when I am talking about the correlation, correlation can help you to understand in which direction two variables are going. Is it clear?
Yes, ma'am.
Then there are various types of correlation available, like simple, partial, multiple, linear, non-linear, then simple, partial, linear, non-linear, positive, negative. These are some of the some of the types of correlation, right? Usually, the most important is the positive and the negative. When I say simple, correlation meaning is what? When you are studying the relationship between the two variables only. This is known as simple correlation. Partial meaning is what? When you are studying few variables, or when you are studying the relationship between the few of the variables by keeping other variables constant. It is known as partial. When you are studying more than two variables, it is known as multiple. Linear is when you say there is a same proportion changes coming in the both the variables. Means if you are changing one variable by a particular unit, suppose x unit, and the y variable or the other variable is also changing by the x unit, it is known as linear. So proportion of change will always same in the linear correlation. Non-linear, the proportion is not same. When you are changing one variable by x unit and other variable is changes by y unit. In that case, you can say this is non-linear correlation. Positive and negative correlation is very important. So here, firstly, I'll talk about positive. Positive meaning is when the change of direction is same. Means you are increasing one variable, other variable is also increasing. That is positive. Or you are decreasing one variable, other variable is also decreasing. That is positive. Right? So the direction of change will always be same in case of positive correlation. When we talk about negative, so it is vice versa. When the change of direction is not same or opposite is known as negative correlation. Means when you are increasing one variable, other variable is decreasing, or when you are decreasing one variable, other variable is increasing. So the inverse relation they are having. It is known as negative correlation, right? Generally, when the price of suppose I'm saying sugar is increasing, the price of sweets will also increase. So it's a positive correlation, right? When the price of suppose petrol increasing, so maybe consumption may be decreasing of the petrol, so that is a negative correlation, right? So that way around us we can see so many things where the variables are sharing positive and negative kind of correlation. Is it clear?
Yes, ma'am.
Yes, ma'am.
Next, how to measure correlation, right? Or how to measure relationship. So there are various coefficients given when we talk about correlation. One of the important one is Carl Pearson's coefficient of correlation. So Carl Pearson's coefficient of correlation we are using to measure the relationship between the two variables, and we are representing this by the small r, right? So this is Carl Pearson's coefficient of correlation. Now this R is having certain values. This ranges in between -1 to +1. So the minimum value of R can be -1 and maximum it can be +1. Right? Okay, I think we cannot use symbols. Fine. So it is minus. Fine. So -1 to +1 is the value or range of the R. Now, if suppose you are getting the value is -1, so the meaning of this is perfect negative correlation. When the R is +1, it is perfect positive. Meaning is very simple. Perfect positive, perfect negative means if meaning is that when you are saying -1, that is perfect negative. That means if you are changing one variable by 1 unit, it means suppose you are increasing it, so other variable will decrease by 1 unit. Is it clear?
Yes, ma'am.
Fine. Moving next, suppose R is coming. Sorry. Anything anyone wants to say? When R is ranging from 0.75 to 0.1, it is generally known as a strong correlation, right? When it is between 0.5 to 0.75, it is known as moderate. When it is less than 0.5, it is low or weak. Generally, this is we are using, but maybe sometime it happens students are studying, so we can maybe classify point means 0.5 to 0.25 also, and then below 0.25 also. So up to the people, but broadly, when the value of R is coming less than 0.5, we can call it as a weak correlation. Between 0.5 to 0.7 is known as moderate or average kind of correlation. Above 0.75 is strong. Then according to the symbol, if R is coming plus, so you can call it as a positive strong, positive moderate, positive low correlation. If the symbol is minus, so you can call it negative strong, negative moderate, or negative low correlation. Right? So according to the symbol, you can comment on the direction. Done?
Yes,
Yes,
ma'am.
ma'am.
Now the next thing is, usually some of the people are misperceiving correlation. That is, correlation is a causation. So correlation is not a causation. So you can write correlation is not a causation. Meaning is not causation, meaning is not, meaning is what, that correlation is not studying cause and effect relationship. That if you want to see the impact of one variable on other, that study cannot be done using the correlation. As I said, when we are observing this thing that price of sugar is increasing, so we understand this thing that the price of sweet will also increase. So there is a positive correlation. Both are going in the same direction. So direction and strength, you can say. If I'm saying there is a point, if you are saying there is a 0.8, R value is coming as 0.8, that means there is a 80% relationship between these two variables. If you are changing one variable by 100%, other variable will change by 0.8% or by 80%, right? But if you want to say this thing, this variable is impacting that variable, that you can understand by your own, because you are a human being. So you can understand this thing, but correlation can only tell you that these two variables are related. But impact of which variable on which variable, that cannot be studied using the correlation. Is it clear?
Yes, ma'am.
So to overcome this, we are having the regression available with us, right? So I think I'll discuss regression once I'll explain you how to perform correlation. So this is about the conceptual aspect of correlation. I hope it is clear to everyone. Any doubt in this?
No, ma'am.
Fine. So now we'll see, we are having the data, temperature in Celsius and the cells of screen. If these two data or column or the two variable values available with us, we need to see whether these two variables are related to each other or not. Although we know this thing, generally when temperature is high, so generally sales of ice cream increases as summer is now reaching us, or it is very close. So we know this thing, generally the price of the sales of sugar will increase as the temperature will increase, right? So we can see using a function I'm telling you, which is equals to CORREL. This is the function which you are going to use. And then you need to give the range of your first set of data and then the range of your second variable. That is A2 to A7, comma B2 to B7. Done?
Yes, ma'am.
So you can find the correlation is coming as 0.774299, which is, can anyone comment which kind of relationship is having these two variables?
And it's
Strong
strong.
correlation.
Strong positive.
Yes, ma'am.
It's a strong positive correlation, and it is quite obvious. When temperature will increase, sales will also increase. Temperature will decrease, generally sales will also decrease of ice cream. Quite obvious, right? So there is a positive correlation. Fine.
जी मैम जी.
Now, using the data analysis tool pack, also we can apply this. So you need to go to the data tab, and here I'll select the data analysis tool. Here you need to see at the fourth position this correlation is available. You need to select this and click on the OK. There you need to provide the range of your data. Data is in the column grouped by column. So by default is the column. We'll go with this. Labels I have selected because my range is A1 to B7. So I'm selecting this checkbox. For getting the output, I am selecting the first option. And in the box, I am giving the reference of the blank cell. Done?
Yes ma'am.
You can press OK to get the output. Now you can see it is indicating we are having temperature variable, ice cream sales of ice cream variable, similarly temperature and sales of ice cream. Now in the same variable, means when I am talking about this temperature and temperature, so it is quite obvious it will be 1. When you are finding the relationship between the same set of data, it will always come 1, right? Similarly, sales of ice cream and sales of ice cream, it will be coming as 1. Done.
Yes.
Clear? Then talking about temperature and sales, you can see temperature and sales. You can see it is coming as 0.77429, which we have got here also. So these two variables are indicating a positive or a strong positive correlation, right? So that way, using the data analysis tool pack also, we can get the value of correlation. Is it okay?
Yes, ma'am. Yes.
Very simple, right? Very simple test in statistics. Fine. And the problem with this is one. The problem is what? Here you cannot say the relationship is significant or not, because in Excel directly you cannot get the significant, that is the p-value. If you are having the significant value, you can easily comment whether the relationship is significant or not, but we are not getting that significant value or the p-value here. So that is a drawback of Excel. Okay. Fine, everyone.
Yes ma'am.
Yes, ma'am.
Yes, ma'am.
Next sheet is the practice sheet for you that you can use for your practice purpose. I'm coming to the regression now. Fine. So firstly, we'll discuss its conceptual aspect. What is regression? So shall I?
Yes ma'am.
Okay. So as I said, first thing, I said correlation is not the causation. That means if you're interested to find cause and effect relationship, that means which variable is impacting which variable. In that case, rather than using correlation, you will use regression, right? Because in case of correlation, there is no independent variable. Correlation doesn't consider the two variables as dependent or independent, right? But when I talk about regression, in regression, you need to be very much clear that which is your independent and which is your dependent variable. So this is a requirement in case of regression, right? So when I say regression, we are using regression for the prediction purpose or forecasting purpose, right? Apart from that, you can get the algebraic relationship between the variables, or you can model your variables. So these are the uses, or also you can write causal or cause and effect. That is impact of one on another. This type of study using the regression. So these are the uses of the regression, right? I think all four are. Is it clear?
Yes,
Yes,
ma'am.
ma'am.
Okay. So in case of correlation, we have seen they're getting the value of R in the range of -1 to +1. And I think 1 is a number that we can say it's 100%. 1 is generally 100%, right? Because when I say this, what I say, as I say, when I'm saying R is coming 0.8, that means there is a 80% relationship the two variables are sharing, right? Similarly, when I say regression, regression is not talking in terms of percent, it is talking in terms of algebraic. That means you can define the relationship in the form of numbers. That is regression does, right? Apart from that, you can predict your dependent variable using your independent variable or variables. If you are having one dependent, one independent, you can predict your dependent variable using your independent variable. Apart from that, you can model your variables. Model your variables meaning is what? You can set a what I can say equation kind of thing. Using that equation, you can go for the prediction, right? So I think in the school time, we all have studied a very simple line, which is this. Sorry. So can anyone tell me what this is? Anyone?
Don't know, ma'am.
Okay. I think
Linear equation in one variable.
yes. Who said this?
Chandan, ma'am.
Chandan, sir. Very correct. This is known as the linear equation, right? And the power of variable is maximum one, right? So that means that is why we are calling it as a linear equation. If I'm making it y equals to a plus bx square, that will be quadratic equation, right? I think in maths we all have solved all these type of things. So this is a generally modeling way in the statistics. We are model our variables here. So as I have written all these things, these all are related with this equation only. Because here we are talking about the linear regression, right? So here I am saying generally you can find y is equals to, I think alpha will be with okay. So suppose I have written alpha plus beta into x. Generally in stats, alpha beta type of things we are using instead of a and b, but meaning is similar, right? So here we are means this is a mathematical equations, but in statistics we are adding one more thing here, which is known as e. So meaning is what we'll see here. Here we'll write y is your anyone which variable it is. Anyone? Y is which variable?
Dependent variable, ma'am.
Very good. Y is the dependent variable. Alpha is the intercept and beta is the slope and x is the
Independent variable.
independent variable. So this is the meaning of these different syntaxes or the symbols. E is error or residue, right? Generally, when we say we are predicting our dependent variable using the independent variable, so I am interested in the prediction part. So if I'm predicting my y variable using the x variable, so suppose I think I have taken, suppose I'm taking the advertisement and sales example, right? Because in this is a very simple way to understand this regression. If I say advertisement, expenditure, and the sales. So if I'm having these two variables, can anyone guess which variable will be the dependent and which variable will be the independent here?
एडवर्टाइजमेंट एक्सपेरिमेंट ये होगा इंडिपेंडेंट वेरिएबल और सेल जो होगी वो डिपेंडेंट वेरिएबल.
Very good. Who was interacting? I don't know the name because I
Rana
cannot
Saeed.
see. Sorry?
Rana Saeed.
Okay, Rana says, ma'am. Fine. Thank you so much, ma'am. Ma'am has said correctly. Advertisement expenditure will be the independent variable and the sales will be the dependent variable. If you will understand the situation like, suppose I say, usually companies are investing very heavily in the advertisement, right? We know, means all of us know this thing. Somewhere it is not necessary. Sometimes we can say few people are looking or watching the TV. So paparazzi, few people are watching the or surfing the so many different social media platforms, right? Or apps, using apps also people are watching the content nowadays, right? So that way we all have experienced this thing. Nowadays advertisements are flashed everywhere, right? That means the purpose is very simple. Companies want to knock out the mind of the customers. They want to make them aware. They want to inform them that what the new things are coming for their product and something like that, or what type of discounts or some things or deals are coming for the customers. So that way the companies are investing very heavily in the advertisement, right? Purpose is very simple. Companies want to increase their sales, right? So that way we can say advertisement expenditure will be the independent variable and the sales will be the dependent variable. Correct?
Yes, ma'am.
Now suppose I have done a modeling or I have set a linear equation using these two variables. So my line will be sales is equals to alpha plus beta into advertisement expenditure plus E. Now E is what? E is the residual or the error term. That means it is the difference. Your error is nothing but is a difference of actual and the predicted value. Right. So suppose using the equation, I'm predicting the sales for the company for the next month. So whatever is the predicted sales according to that, for that particular month, we will be having the actual sales also. So we can compare or we can take a difference of actual and predicted. So that way we will be having some term, because always means it is like whatever you are predicting, that will not be always 100% accurate, because the sales is depending on so many other factors. We are predicting the future and future is uncertain for us. We are not knowing which factors will be coming at that time and what can impact what you are predicting, right? So that way, maybe you have predicted the sales of the company will be suppose 2000 units, right? But maybe suppose actually it is coming to the 1800 only. So that way the difference is of 200 units. Getting me? This is known as the error in the prediction. Clear?
जी 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 मैम.
Fine. So that is why to balance this particular equation, we are adding E. Up depending means it is depending if E is plus, so you can keep the plus value. If E is negative, you can keep the negative value, and that way you are balancing both the sides. So that is why we are adding a new term or the next term, that is error here. Clear? So this is the difference in the mathematical equation and the statistical equation. I hope it is clear.
Yes, ma'am.
Fine. So this is one thing. Now talking about the type. So in case means although there are varieties are available in the regression, but when I'm talking about the linear regression, so there is simple linear and multiple linear. Simple linear is what? Anyone will attempt? Anyone?
Y equals to mx.
Sorry?
Y is equal to mx.
Y equals to mx. Okay. Can you explain, sir? It is not clicking me. What do you want to say?
It is a linear increase. When one parameter is increasing, the other also increases proportional. It is directly proportional to one another.
Okay. Okay. Fine. Okay. Okay. Anyone else who wants to comment on this? No comment?
Ma'am, probably it is like a linear relationship which describes the correlation between a independent and the dependent variable. Simple linear regression.
Okay. Fine. Good. I think people are thinking very good. I think most, I can say people are almost very near to the answer. When I say simple linear regression, it is quite obvious when I'm saying linear, that means two variables will be sharing the linear relationship here. And when I say simple linear, that means we will be having only the two variables. That is one dependent, which will be your numeric, and one independent, which will also be numeric or continuous, right? In case of multiple linear, means variables will share the linear relationship here, but we will be having more than two variables. That is one dv, which will be your numeric variable, and more than one iv, it can be numeric or categorical or both, right? Means we will be, in both the cases, we will be having only one dependent variable, and always the dependent variable will be here numeric in case of linear regression, right? And independent variable will be numeric in case of,
एक्सक्यूज मी मैम
yes ma'am,
मैम इसमें ऐसा भी हो सकता है कि मोर देन वन should be dependent variable and one variable is dependent variable
no,
in multiple linear.
no, always one will be the dependent here. That is what I said. That is what I was repeating. I said always there will be one dependent variable in both the cases, and always the very dependent variable will be numeric here,
Okay, ma'am.
right? Because it is simple linear. But when you will go for logistic regression, so in case of logistic regression, your dependent variable will be categorical, binary nature, right? So
Yes.
yeah. So when I say multiple linear regression, dependent variable will be numeric, and we will be having more than one independent variable. And that more than one independent variable will be, these can be, all the variable can be either numeric, or all can be the categorical, or they can be in the combination of numeric and categorical variables, right? So any combination it can be for the independent variable. Is it clear?
Yes, ma'am.
Fine. So I think now we'll, okay. I hope you will have got the clarity about the regression also.
Yes, ma'am.
Yes, ma'am.
Fine. Now we'll see. We are having a data available in the regression sheet. You can see the data is of COVID cases and the mask sold according to the 12 months given to us. So this is the very bad phase every one of us have seen. So generally we can correlate with this thing, and we can comment if we are having the COVID cases data and also the mask sold data. So which will be dependent and which will be independent variable here.
COVID cases is independent and mask sold is dependent variable.
Very correct. So mask sold is your DV, and COVID cases will be IV. Done?
Yes, ma'am.
Now, if the variable clarity is with us, we need to formulate the hypothesis here. So can anyone try? What will be the hypothesis?
There is no relation between significant relation between the COVID cases and masks sold.
Okay, good, ma'am.
Impact. Okay.
Right?
Yes, ma'am.
Or there is no significant influence.
Hmm.
Done?
Yes, ma'am.
So this way we can formulate the hypothesis. We want to see the impact of dependent on the we want to see the impact of independent on the dependent. Now, I think it is when we have got the clarity, we will now apply the regression. So for that, we are going on a data tab and data analysis toolpath we are selecting here. Then, as we know, this particular dialog box is having all the tests listed in the alphanumeric in the alphabetical order. So you need to go down to find regression. So I hope you will be able to locate this. Done?
Yes, ma'am.
Now you can click on OK. So the dialog box is appearing. Here it is asking you clearly the Y range and X variable range. That means the independent and dependent variables range we need to provide. So Y is always your dependent variable. So we have just discussed that the mass sold will be the dependent variable. So you can select the range. Then range is C1 to C13 in my case. Then input X range, that means the COVID cases variable data we have selected. The range is B1 to B13 in my case, right? So that is why you can see I selected the data including the first row. That means there are the labels available. So I need to check this box also. Done.
Yes, ma'am.
Then you can come to the output and I'll select the blank cell here. Then I did this. Then the remaining section which you can find at the bottom, these are related with the what I can say, the assumptions part. If you are checking, you want to check the assumptions, right? So for checking those assumptions, you can select these different check boxes. So you can find one is related to, this section is related to residuals. So whether your residuals are independent or they are having any relationship, because one of the assumptions of regression says the the residuals should be independent, means they should not be related to each other. So to check such kind of relationships or kind of assumptions, you can go to this particular section. Similarly, to check whether the residuals are normally distributed or not, you can select this normal probability plot. So if you wish to
Ma'am,
check, yes,
प्लीज ये रेसिडुअल को भी समझा दीजिए. Please explain, ma'am.
which one?
Residual.
This is what I am explaining. I'm saying this section is for checking the assumptions. In regression, most of the assumptions are related to the residuals. One of the assumptions says that the residuals should be independent, means there should be no relationship in the residuals. So to check that, you can select these options. One assumption says that the residuals should be normally distributed, means instead of asking the dependent variable is normally distributed or not, regression asks you to check whether the residuals are independent or not, or whether whether the residuals are normally distributed or not. So these are the assumptions in the regression. So if you wish to check those assumptions, you can select these different check boxes. Right? I think we do not need to calculate standardized residuals. So this is, you can select, and that way you can get the output. Once you will click on OK. So I hope it is done.
Yes, ma'am.
Okay. I hope everyone has got the same type of output. Done? In my case, graphs came, I don't, yes. Done?
Yes, ma'am.
Fine. Now you can see firstly. Firstly, I'll talk about this output. This output is the summary output, the first output, right? So you can note down what is the meaning of these things. Some of the things are important which we need to report. The first one is the multiple R. This is generally the name which is what I can say saved in the Excel to give the output. Multiple R is nothing but it is a correlation between the variables. R is correlation, right? So it is indicating your two variables, that is COVID cases and mass sold. There is 0.98 relationship existing. That is 98% relationship is existing between the COVID cases and the mass sold. So it is a strong positive correlation. Done?
Yes, ma'am.
Then talking about R square. This is you need to understand when I talk about R square. This we are reporting in case of simple linear. And this we are reporting in case of multiple linear regression. So here we are talking about, we are having the simple linear regression problem. You can see we are having only the COVID cases and mass sold. So one dependent, one independent we are having. That means this is a case of simple linear. So you will go for only reporting of your R square. Adjusted R square we will report in case of multiple linear regression, right? So you can see R square value is coming as 0.96. So meaning is that it means 96% variance in DV, which is your mass sold variable, is explained by IV, that is COVID cases. Done? So how much percent variance in the dependent variable is explained by your independent variable? This is what you need to write, use as an interpretation of the R square. Adjusted R square interpretation will always also be same. Only the difference is this: when you are having the multiple independent variable. So for the purpose, you need to use adjusted R square. In case of single independent variable, you need to report this R square only. But explanation will be same of both. Is it okay?
Yes, ma'am.
Then adjusted R square, I think I'm not discussing or not writing the explanation because it is not applicable in this case. Standard error is coming as 141.848 and the observations are 12. Next is the ANOVA. ANOVA will also come when you are talking about the regression. So ANOVA is again a kind of precursor. Correlation and ANOVA, these two are the prerequisite for performing the what I can say regression, or maybe I must say that correlation is a must prerequisite, because if two variables are related, only then we can understand that one is impacting other. If two variables are not at all related, then how one variable can impact the other, right? Suppose rain is happening. So I am talking about, I am having a rain quantity data, and I want to see the, suppose, petrol prices might be possible. So these two variables are, there is little doubt these two variables will be related, right? So that way, two unrelated variables, if you are taking that way, you cannot see the impact of one on other. Or if you are trying to see, you will not get the good results. The results will be very poor, right? So that is why correlation is a kind of prerequisite to perform regression. So that is why you have seen the first output is coming as a multiple R, that is correlation value, right? Now, ANOVA is also one of the important part in case of regression. This is telling you whether your model is a good fit or not, or whether the straight line which you are fitting using the variables, whether that line is a good fit or not, right? So you need to see it's, we are having the significance value, which is this. So if I want to conclude this, I need to compare this by the level of significance, which is 5% or 0.05. You can see this thing, it is less than 0.05. That means you will comment model is a good fit. Done.
Yes, ma'am.
Shall I proceed?
Yes, ma'am.
Next is the coefficient table. This is again a very important table. Generally, you need to report till here, right? Here you need to see the coefficient values are coming as minus 245, means your intercept value is minus 245.63. COVID cases coefficient value is 0.9945, right? But before reporting these two values, you need to see whether these two values are significant or not. So here the t-test will come in that case. To check the significance of these coefficients, we will using t-stat and its p-value. So you can see the p-value in both the cases is less than 0.05. If I'll talk about this, this is also less than 0.05. This is also less than from 0.05. That means both intercept and the coefficient of COVID cases both are significantly impacting your dependent variable, right? Clear?
Yes, ma'am.
So I think now we can make a regression equation. So I'll write the equation here. I can write mass sold is equals to minus 245.63 plus 0.99 multiplied by so the meaning is this: if I am ignoring the intercept, if I am not considering the intercept, I can say there will be 1 unit change in the COVID cases, or 1 COVID cases increases. So there will be 0.99 change occurred in the mass sold, right? So it is 0.99 of the number of COVID cases will be giving you the mass sold value, that how much mass will be sold. Is it clear?
Yes, ma'am.
1 unit change in the COVID cases will lead 0.99 change in the mass sold, right? Is it clear?
Yes, ma'am.
Fine. Next sheet you can find. Okay, just a minute. I need to talk about where is the graphs. Yes. Now you can see the graphs. There is my third graph. Fine. You can find here. You can see when I talk about the COVID cases residual plot, that plot you can see Here you need to see these points which are scattered or shown you by the blue colors or rectangles. You need to see these should be equally distributed above the zero and the below the zero, right? Almost same kind of proportion should be there at the upper side and the lower side of this middle line. So almost we can find this is a quite good distribution. Whether your residuals are normally distributed or not, that you can check using this COVID cases line fit plot. So you can see it is showing the what I can say, the blue one is indicating mass sold value, and the what is rectangle is indicating the predicted mass sold value. So it is indicating both are following almost each other. That means these are positive or these are normally distributed. Clear?
Ma'am.
Yes. Yes. Anyone who's asking something? Nothing. Done. Then at the bottom you can find these are the predicted mass sold value and these are the residuals. So we are having the actual values of mass sold, these, and that way you can see the difference. Take the difference of this. This will give you the residual value. For all the months, for the first month, this is the residual value. For the second month, residual value. Likewise, you can find. These are the residual values coming. Then is it clear to everyone?
Yes, ma'am.
Then I think this is the simple linear regression. Now for the multiple linear regression, you need to go to the MLR sheet. Multiple linear regression sheet. There you can find, rather than giving the name, I have written x1, x2 and y. Means these two, x1 and x2, these two are your independent variable and y is your dependent variable, right? Now to perform multiple regression, you need to again go to the data analysis, and again you will select the regression and click on OK. So here I think I am closing or deleting all these things. Now I'll select the range of my y variable in the input y range. Just a minute. And in case of input x, you need to select both the variables simultaneously. Done. Checkbox of labels is already selected because we are using the performing this these tests in the same sheet. So previous selections will be shown to you, right? Instead of this, I think it is coming correctly. I'll go with this only. And this time I think I'm not selecting all these. You only go with and see what it generates for you. So this is all what you need to do for getting the output. I hope it is simple. May I proceed?
Yes, ma'am.
So now you can find the same type of statistics we are getting in case of multiple regression also. This is indicating that the multiple R or the correlation is coming as 0.836. That is against the strong positive correlation between the variables. Then talking about R square. This is, I think, as I said, we will not report. This is a case of multiple linear regression. Instead of this, we need to report this. Always your adjusted R square will be lower than your R square value. It will always be, right? You can see this is indicating 61.4% variation in Y will be explained by X1 and X2 simultaneously, right? You can write. It shows that 61.4% variance in Y is explained by X1 and X2 both. Clear?
Yes, ma'am.
Fine. Total observations we were be having as 10. Talking about the ANOVA table. So looking at the ANOVA table, significant value, I think we can say it is less than 0.05. When it is less than 0.05, meaning is that we can say the model will be a good fit, or model is a good fit, right? Using this data. Coming to down, we can see intercept, then x1 and x2. In this case, you can check the p-value. Any comment on these p-values?
Ma'am, they are less than 0.05.
Very good. That means intercept and the coefficient of x1 and x2 both are significantly contributing to your dependent variable. So your line will be y equals 43.109 minus 0.818 multiplied by x1 plus 2.418 multiplied by x2. Done? Fine.
Yes, ma'am.
So this way, using Excel, we can perform correlation and regression. I hope it is clear to every one of you.
Yes, ma'am.
Okay. Okay, fine. No doubt in this. Any doubt you are having? Anyone? No doubt?
No.
Fine. So I think I'll take at least 2-3 situations so that you would be able to understand these things. So I think I'm showing you a Word file. Visible, I hope.
Ma'am, can you please confirm about the regression output that we get? If the F value is less than 0.05, is it? Significance value?
By default, it is 5% in the software. Yes, ma'am.
Right. 0.05, then the model will
Is
be
a good fit.
acceptable, right?
A good fit, yes.
Okay, okay. Thank you so much, ma'am.
Yeah. Now you can see the first situation I'm showing you. I'm expecting you to read it and try to understand in this situation which test we can perform.
Chi-square test will be applied.
Okay, Rana ma'am. What about others? Any other opinion?
एनोवा भी लगेगा.
Sorry?
एनोवा भी यूज होगा. काई स्क्वायर भी लगेगा. काई स्क्वायर वैसे इसमें ऑब्जर्व्ड और एक्सपेक्टेड आउटकम मालूम करने के लिए.
Okay. Okay. So Kai or ANOVA or both? Ma'am? Kai or ANOVA both is possible here?
Chi-square will be used.
Chi square will be used.
Only काई स्क्वायर.
Only chi square. Fine. Any other opinion? Nothing? No opinion? Everyone is agreeing with the two persons. I think two ma'ams has said it will be a chi square. Everyone is okay with this?
Yes, ma'am. Chi-square will work.
Okay. Can anyone comment why we will go with the chi square? Yes. Okay,
Because
fine.
your observed and expected frequency is given.
Yes, frequencies are given, right? We are having the categorical variable available. That is the various genre of movies are given. Genre of movies are given. We want to see whether the distribution is same or not, right? Fine, everyone.
Yes, ma'am.
Yes.
Yes, ma'am.
Okay, one more situation.
Correlation.
Okay,
Right there.
okay. Any other opinion?
Ma'am, is it t-test?
Yes, two-way t-test.
Yes, ma'am. Paired t-test.
Paired.
Fine. Don't you feel so it should be ANOVA? How many variables are there?
Mm, Technical leadership.
Leadership sales. Yes, more than two
Yes,
variables.
ma'am. There
No
are more
variable.
than 2 variables, so we can go for ANOVA.
Yes, type of training programs we are having. We are having the type of job roles and we are having the performance variable, right? And interaction also, word or keyword I mentioned here. That means we can go for the two-way ANOVA, right? Not
Okay.
one way,
Okay.
two-way. Because
Okay,
two categorical and one numeric variable we are having. And we want to compare or we want to find the interaction effect of both the categorical variable on the performance. Fine, everyone.
Yes,
ma'am.
ma'am.
Shall I take one more?
Yes, ma'am.
Yes.
Correlation, ma'am.
Okay.
Yes, ma'am. Correlation.
Okay. Anyone else?
Ma'am, is it ANOVA?
It's ANOVA. Which ANOVA?
Ma'am, is it one way or
It's one-way ANOVA.
Yes, ma'am. One way ANOVA.
Very correct. It's a one-way ANOVA problem, right? I think this way you can write the problem. These are the three different schedules available with us, and you can write the productivity values of the all the 60 employees, right? Which are coming in these different shifts or schedules. Fine, everyone.
Yes, ma'am.
Yes, ma'am. Yes.
Okay. So I think on this note, I'm concluding the FDP. in this FDP, I think I tried to explain you few of the very basic statistical tools, like descriptive statistics we have seen. We tried to understand the one non-parametric test, which is the chi-square test. Both the forms of chi-square I tried to explain you, that is goodness of it and independence of attributes. Apart from that, we have seen the parametric test, like we have seen the t-test, ANOVA, coercion and regression. And we have seen the conceptual aspect of all the tests. And also we have seen how you can apply using the Excel and how you can interpret the output. So this is what I think I tried to explain you during this FDP. So friends, I hope this FDP will help you out to clear your doubts or maybe the things which you are facing during performing this test. So maybe Excel can help you out in that manner, right? So this is all from my side. Now over to you. If you are having any query, please ask me. Yes.
Excuse me, ma'am. I want to
Yes.
know for how many days the videos will be available on YouTube, because while practicing we will be facing problems and then we must be clarifying from YouTube. Is there any time limit for the videos that will be available on YouTube?
I don't think so. I don't think so. There is a limit. It's available on YouTube, ma'am. So you can access anytime.
We can watch them anytime, according to our convenience.
Yes, yes, yes.
Okay, ma'am. Thank you so much.
Thank you so much, ma'am. Yes. Any other doubt? Nothing? No questions? Okay, so it is possible. May I ask you to switch on your cameras? No? Anyone? Okay, I can see few faces. Just a minute. Just capturing you all. I can see Kuljit ma'am, Samir sir, Shabina ma'am, Girja ma'am, Radhika ma'am, Mohammed Sheikh sir. Okay, I can see. Thank you for switching on your camera so that at the end of the day I can see to whom I was interacting since last 5 days. Yes, I think one more face, Harpreet ma'am, Jasmine ma'am. Thank you everyone. I think it was nice connecting and interacting with you all. And I think thanks to Samir sir for giving the idea of interacting. Thank you so much, Samir sir. I think this type of exercises I think we are not doing, but it's good ice breaking.
Yes, ma'am, because there are so many people from so many different fields.
Yeah.
That I know
Right.
statistics only from my point of view, but so it is always nice, ma'am, to meet everyone.
Correct. Very correct.
Thank you so much, ma'am. It was wonderful learning from you. But then when it comes to statistics, the problems, like you keep asking us very generously, tell us the problems. So perhaps once we are using the tips given by you, the learnings that we've got from you, we are using it, we'll perhaps be able to tell you the kind of problems we are getting. But I'm sure when we are facing the problems also, we can get back to your videos on YouTube, and I'm sure the problems will be solved. Thank you so much, ma'am. It was wonderful learning from you once again.
Thank you, Harpreet ma'am. Thank you so much.
Thank you so much, ma'am.
So I have a question, ma'am.
Yeah.
Can we have all the recordings on the shared YouTube links only?
Yeah.
Okay. And the other doubt is related with the certificate. Obviously, that is last but not least. So how and when we are going to have our certificate?
I'm not the right person for that. RFI team will answer you.
Okay. So then,
Ma'am, for a doubt I had that I have done few meta-analysis, so I am very, used to Revman. But if you have some program for network meta-analysis, that will be good and that will be helpful for me.
Okay, sir. If we are planning, definitely we will launch some program with RFI. Right now, I'm planning to launch the analysis program in the multivariate analysis. Probably I'll come with the multivariate analysis first.
Okay, ma'am.
Yeah.
Thank you, ma'am.
Thank you so much. Anything
thank
else?
you.
Can we call off a meeting for the day, right?
Yes, ma'am.
Thank you.
Yes, ma'am. Thank you so much, ma'am.
Thank you, ma'am.
Madam, thank you.
Thank you so much, ma'am.
Thank
It
you.
was nice association with you, ma'am. Thank
Thank
you.
you.
Bye, madam.
Bye, ma'am. Thank you.